most important thing when it comes to circle geometry and Euclidean geometry is they are trying to give you hints in the way that they say. So when this first line over here, when they say AB is a chord, all of that, they're trying to give you hints. They're trying to tell you things that are important. Okay, so let's start by reading through this. AB is a chord of the circle centered O. So they're telling you that our center is O. That's important because that means that radii are going to be involved. Okay. AD is equal to 12 centimeters. So we've been told that. And we've been told that BD is the same length as AD because we've got those two little lines. So that's helpful. ED is 8 centimeters. And then OD is X centimeters. So now before we do anything, before we even look at these questions, so don't even look at the questions, my first thing that I'm going to ask you is, what can you tell me about this picture? Any information you can tell me about this picture. I don't mind how simple you may think it is. Anything you can tell me, and I'm going to draw it in for us. What can you see? What can you tell me about the circle? You don't need to give me reasons or anything. Don't be scared. Come on. I'll even give you a little hint to get you started. What can you tell me about this and this? Yeah, okay, beautiful. The direct message that just came in, you can, that's perfect, okay. DB is equal to 12. I love it. Good, pop it in. What can you tell me about those two lines that I highlighted? What are they? You don't have to give me values. Just tell me something important about them. So you can either pop your answer. Great, that's perfect. Okay, so AO is equal to OB. Absolutely, they are the same as each other. Who can tell me why they are the same as each other? Why are AO and OB equal to each other? What are they? What makes them the same? Remember, if you're wanting to answer out loud, you're welcome to unmute yourselves and just talk. I don't mind. Because sometimes it's just like a quick answer and it's easier than typing. Why are OA and OB the same length as each other? What are they? They're something cool. Yes, exactly. They're radii. Beautiful. Okay. So they are radii. That means that they are going from the center of the circle to the circumference. Okay, so they are radii. There is another radii in this picture. What is it? What is my third radii in this picture? What are the letters of my third radii? Yes, beautiful. EO. Okay. So just by taking that moment and sort of establishing some things to us, it's going to help us a lot as we move forward in this question. Okay, so let's have a look at question A. A says determine the radius OB in terms of X. So that means that we need to give an answer that's going to have X involved in it somehow. We can already see, well, they've told us that ED is 8, and they've told us that OD is X. So with that knowledge, who thinks that they can tell me what OB is going to be equal to? Yeah, beautiful. Inam, that's a great start. Let's start with that. Okay, so let's say OB is equal to OE. What would my reason be for that? Why are they equal to each other? You've already told me earlier. What are they in the circle? As a hint, the word is somewhere on the page. There we go. There we go. They're radii. Okay. So we're going to say, sorry, guys, my writing is probably not nearly as neat as Teacher Sam's. I'm out of practice. Okay. So we can say OB is equal to OE because they're radii. What is OE equal to? If I had to give it, so what's the value of this whole line, OE? Looking at what we have in our picture. Don't be scared to take a chance. And remember, if you send me direct messages, it's absolutely fine. Okay, so that's very close, Inam. That's very, very close. And I'm so glad that you wrote that. If I write 8x, that's meaning 8 times x, okay? And we're not going to be multiplying x by 8, but we are going to be adding them together, right? So we're going to be saying that OE is going to be 8 plus x. And I'm just going to put this in brackets and say centimeters, just because it's going to make our life a little bit easier later on. Okay. Let's make our lives even easier. And instead of writing 8 plus x, because you'll see why soon, let's write it as x plus 8. Just to make our life even easier as we move forward. So I'm going to say x plus 8 centimeters. Okay. So now we know that this dude over here is x plus 8. Okay. Happy days. Cool. We have done question 1A. Let's move on to B. So B now says hence. Now this is a super important word in circle geometry. Whenever you see the word hence, it means you are going to use whatever information you found out in A, or whichever question was in front of it, you're going to use that information in this question. Okay, hence is saying use what you learned in A, and we're going to use it now. So now they're saying hence, calculate the length of radius OB. So that means we need to try and figure out this length over here. So let's look at this little triangle. What can you tell me about this triangle that might help us in this mission that we are currently on? And you don't have to give me reasons and stuff yet. I'm happy to help you with your reasons. I know that this is the first lesson on circle geometry that you guys are doing. So the reasons might be a bit blurry still, but what can you tell me about that yellow triangle that I've highlighted? What type of triangle is it? My hint is look at angle D. And then tell me what type of triangle this is. Yay, yes, there we go. Okay, it's a right angle triangle. Okay, so this over here is 90 degrees, and we're going to have to give our reason for that. So we're going to have to write why that's 90 degrees before we can write anything else. So we're going to say angle ODB is equal to 90 degrees. And now we have to give a reason. I'm going to give you this one's reason because it's a nasty one and you guys haven't done this for a while. So we're going to say line from center to midpoint chord. Okay, so basically what this reason is saying is if we have a line that's going from the center to a chord, and that chord it's hitting at the midpoint. So this is equal to this, which we already know because they told us then these angles are both 90 degrees. Okay, so that's what that reason is telling us. Now, since we know that that is a 90-degree triangle, I'm going to just quickly redraw it for you over here so that it's not so messy. So we've got x chilling over there. We've got 12 chilling over there. And then we've got x plus 8 chilling over here. If you can go all the way back to even grade 9, I think, how would you work out x in this question? What are we going to use? What is the tool that we can use when we have a right-angled triangle? We've got a glorious tool from an old mathematician. Yes, Caitlin, we are all yours. Tell us.
Pythagoras.
Yes,
Am I right?
Pythagoras. Woo, okay. Pythagoras, okay. So when we have a right-angled triangle, we can use Pythagoras. Now that we know that it's Pythagoras, does anyone remember what the rule of Pythagoras is? Let me write it like with A's and B's and C's so that it's a little bit less complicated. Who remembers what the rule of Pythagoras does? Caitlin, can you tell me the name of Pythag and not its rule? Yes, beautiful. Okay. Yes, I'll chat. That's great. Okay. So when we have Pythagoras, we say the sum of the square of both of our sides. Beautiful, guys. So a squared plus b squared is equal to our hypotenuse squared. Caitlin, no need to cry. Okay, so that is our rule for Pythagoras. So we're going to write that over here. We're going to say x squared, because that's our one side, plus our other side, which is 12 squared, needs to be our hypotenuse. Now remember, your hypotenuse is the longest side of a right angle triangle, and it's the side that's opposite the 90-degree angle. So that's going to be equal to x plus 8, and we're going to keep it in those brackets squared. And then we have to give our reason. So our reason here is Pythagoras. And don't worry if your spelling's not right. They can't take off marks for spelling. Okay. All right. Now we just jump through this. So x squared is just x squared. 12 squared is going to be 144. What's going to happen with this now? Don't fall for the trap. There's a big trap waiting for you with this. Try and put on your algebra brain from the beginning of the year. What is that going to expand out to? 2 binomial brackets. Love it. Love it, love it, love it. Okay, when in doubt, write it out. X plus 8, x plus 8. Do not write x squared plus 64. Okay. Now you can work out using FOIL. So we're going to have x squared plus 144 on the left-hand side. And then we're going to have x squared plus 8x plus 8x plus 64. Okay. My x squareds are going to cancel with each other because I have one on each side, which is great. I'm going to move my 64 to the other side. So I'm going to say 144 minus 64. And on this side, I am left with 16x. Okay. And 144 minus 64 gives us 80. So we're going to have 80 is equal to 16x. How do I find out what x is now? If I have this equation, 80 is equal to 16x. What am I going to do to both sides? Divide! Woohoo! Okay, so we're going to divide both by 16. I'm running out of space because I wrote too big. This is what happens when you're out of practice. Okay, so we're going to divide both sides by 16. Those cancel. So we land up with x is equal to 5. Okay, but that is not what the question said. The question said the length of the radius. Okay, and our radius is x plus 8. So that means that our radius is going to be 5 plus 8, which is going to be 13 centimeters. Does anyone have any questions about the question that is currently on the board? You can feel free to pop your hand up and ask it out loud, or to write it in the chat. You can send it as a direct message or to everyone. I'm happy to answer if there's anything on the screen right now that you are not understanding. I'll give you a little bit of time in case you want to type. Yes, Caitlin, how can I help?
Ma'am, I wanted to ask, by the right angle triangle, could I have
Yeah.
said line from center bisects chord? Because you said midpoint. So I wanted to know, could I
Yeah.
write that in my exam?
That's totally fine. 100% fine.
Okay, thank you, ma'am.
No worries. Apparently, Teacher Sam put all of the rules on your Google Classroom, so you guys can go over those. Maybe, you know what actually might be helpful if you can either write yourselves a list that you can put up somewhere in your room or wherever you work, or if you can print out those rules or you can put that up. It really helps when you go through questions. The worst thing you can possibly do when it comes to circle geometry practice is not write your reasons. I know so many students who just write the answers because they're working it out, and then they don't learn the reasons. And then when it comes to exams, it's a problem. So practice makes perfect. Okay, let's have a look at question 2 with all of my mess around question 1. Okay. We're going to do a very similar thing to what we did in the first question. We're first going to start drawing some things in this picture. All right, so they say, given that AOC is the diameter of the circle, so they are telling us that this is the diameter of the circle. That is super, super important because of one of our rules. When we have a triangle like that, where we have a diameter and then we go to the circumference of a circle, what does that mean about angle B? You don't need to give me the reasons just yet, but what would that mean about angle B? What would angle B be? You can tell me in degrees. Exactly, Samsung SMA245F. It would be 90 degrees. Okay, so when we have a triangle where we're going through the diameter, so the baseline is the diameter of the circle, and then we're going to a point that's on the circumference, that point is going to be 90 degrees. Okay, cool. So let's just draw that in. Let's look what other things they tell us. They also tell us that A1 is equal to X. Cool. So we know now that this angle here is X. And then we are being asked to give a few things. Now, before we read through these questions, I would like you to tell me where my radii are. Which are my lines that are my radii? You can give it to me in letters. So this equals this equals this. I'm looking for 3 lines. I'm looking for 3 radii. Okay, let's see. So we've got OB, love it. OA, love it as well. And OC, beautiful. Okay, love it. Now, if those are radii, then that means that this line is equal to that line, correct? Do you agree with what I've just said? You don't have to agree. Okay. If those two are equal, and we know that angle A1 is x, what is angle B1 going to be in terms of x? I'm going to draw it in a slightly different way, and you're going to be like, oh, I know. Think of it as you can go all the way back to grade 8. It would have been one of the first rules that you would have learned. What is in this little triangle that I've drawn here? What would B be? What would B be in terms of x? If we've got this little isosceles triangle chilling over here. Exactly, Morgan. It would be x, 100%. Okay, because it's an isosceles triangle. So when we have an isosceles triangle, those base angles are the same as each other. So we can start by saying, cool, we know that angle B1 is going to be equal to x. Do we have any brave souls who remember the reason when we're dealing with isosceles triangles? It's a nice long reason. Let's see. Give me your best guess in the chat on what you think it would be. Or if you're feeling very smart, pop onto Google Classroom and find the rule for me. Nice. Good job. I think you guys think I'm talking to myself, but it's because I'm getting direct messages, I promise. Okay. So we're going to say angles. Oh, goodness, sorry. Angles, opposite, equal sides. So we're saying the angles that are opposite of the equal sides are equal to each other. Okay, cool. We've done A. Next one. We're looking at O1. We're looking at this guy over here. So we know that A1 is X and we know that B1 is X. So if we look at this little triangle here, we know that those two are X's. What would O be in terms of X? What would O be in terms of X? What is the sum of all of my angles in a triangle? What does it have to equal? Good, 180. Beautiful. Okay, so I know that if I have x plus O1, that needs to equal 180. Okay. So if I'm trying to find out what O1 is, how can I manipulate this equation a little bit to help me out? So I want O1 to be the subject of my formula. I want it to be the only thing I have left on the left-hand side. What would that look like? What can I do with those x's? That might help. It's a good start. Beautiful. Okay, so O1 would be 180 minus x minus x. But if I'm minusing those two x's, then that's the same as saying minus 2x. So I'm going to say 180 minus 2x. Okay. So we're going to say, oh, goodness gracious. Now my O is traveling. Okay. O1 is going to be equal to 180 degrees minus 2x. And my reason is going to be sum of angles in a triangle. Okay. So now we know that this dude over here is 180 minus 2x. You could have also said exterior angle of a triangle, but let's just keep it easy for now. Cool. So we've done B. C. They would like the angle of C. Now, I've helped you out a little bit when we first started looking at this picture. So I would like to get some answers for what you think the angle C is equal to. Give me your answers in the chat. Remember, if you feel embarrassed, send it as a direct message. That's absolutely fine. I would like to know what angle C is equal to. But everyone give it a go. I will never be upset with you for giving me a wrong answer, only for not trying. Okay, it's a good try. It's a good start. It's not X. Oh my goodness, we've got some brain buffs in this class coming through. I'm going to redraw this triangle to help you guys see a little bit. So far we've got one beautiful answer in the chat. Keep them coming. See if my little red triangle helps you at all. Try and figure it out. Nice. Nice job, guys. Okay. I think based on how you're giving me these answers, I'm going to write this in a slightly different way. So I would say X plus 90. And we knew it was 90 because it was angles in a semicircle. Plus angle C needs to equal 180 degrees. Okay. Now, when I write that, I need to write two different reasons. I first need to say angles in a semicircle, and then I need to say sum of angles in a triangle. But I'm not allowed to write two reasons on the same line because maths is very particular and rude sometimes. So we actually have to write this as two steps. We first have to say that we know that angle B is equal to 90 degrees because of angles in a semicircle. So basically, we're telling the person who's reading our test or our exam or whatever that we know that this angle here is 90 degrees. Because if we don't tell them, they don't know. Okay. Then we can say what we said just now. So then we can say, cool, that means X plus 90 plus angle C is going to equal 180 degrees because of sum of angles in a triangle. And now I'm trying to isolate angle C. So I'm going to say angle C is equal to 180 minus 90 minus X, which means it's going to be 90 minus X. And we have done angle C. Okay. Last one is nice and easy. You can do it in a single line. So one line, one reason. Let's see who our brain buffs are today. Who can give me D? I'm going to give you a little hinty hint to make your lives a little bit easier. Ooh. There's a great answer coming in the chat. See if my little bow tie helps anyone else out. Bonus points if you can give me, Chantel, rocking it, love it. Bonus points if you guys can tell me the reason. So we've got some brain buffs who have figured out the angle, which is beautiful. So angle D is definitely equal to 90 minus X. What would my reason be? Bonus points here, guys. I'm looking for one reason. Ah, yes. Nice job. Angles in same segment. Angle subtended by the same arch is also fine. Totally okay. Perfect reason. Nice job, guys. Okay. Take a screenshot if you would like one. And exactly the same as our previous question. If you have anything that you don't understand or would like a little bit more clarification on, please ask now. This is your time. Ask away. We're going to have time to go over one more question today. So please don't panic. If there's something that you don't understand, just ask. If you write it as a direct message, I will not mention your name. I will just give you the answer. Oh, happy. Okay. All right. Let's go on to our last question of the day then. Okay. We're going to do the exact same thing. We're going to, before we even read our question, we're going to write out some things, because I know as soon as you see these pictures, you panic. You're like, oh my gosh, there's letters and there's lines everywhere, and what am I supposed to do? But if we read the question slowly, we can draw things in. Okay. So they've told us that we've got a circle with center O. Now, as soon as they tell us that we have a circle with a center, they're telling us that there are radii involved. Okay, so what are my radii in this circle? What are my radii? What two lines are the same length as each other? Beautiful. OA and OC. Oh, sorry, Luyanda, I just see your hand now. Beautiful. Okay, let's write that in. So let's say we're not answering any questions yet. We're just writing what we've done. So we know that OA is equal to OC because they are radii. So now remember, as soon as you see in the information that you've got a center of your circle, look for radii. Okay. Next, they're telling us that tan, so TAN, is tangent to the circle. So tangent means it just touches at one spot on the circumference at A. Now, when we have a tangent, we generally have two different things that we need to look at. We either need to look at tan chord theorem. Okay, so tan chord theorem. Oh, is theorem with an E at the end or an O? Now I'm worried I'm writing this wrong. No, I think that's right. I think it's E. Theorem. So I'm sorry if I'm spelling this wrong, guys. I'm a mathematician, not an English person. Okay, tan chord theorem. Let's draw ourselves a little triangle. So tan chord theorem is basically saying that if we have a tangent, which is this line over here, okay, and I want you to imagine a little person who's windsurfing. So this is my little windsurfer on my ocean. The angle that they're looking at would be the same angle as that person. Okay, so those two would be the same as each other. So that's our tan chord theorem. And the other thing we want to look at when we have a tangent is if we have a tangent, the terrible tangent that goes to the center of our circle, then that's going to be at 90 degrees. So that's at 90 degrees over there, basically. Okay, so those are the two things that we want to look at when we have a tangent. Nice. Okay, what I've given you there should help as we start working through these questions. So let's go right to the beginning. A. So we are trying to find A. Caitlin, yes, tell us good news.
And making me nervous with that. Tell us good news. Ma'am, this is for D. If
Yeah.
we use the tan chord theory D, doesn't that mean that B equals 58?
Absolutely. So in this case, our angle A is going to equal 58, 100%.
Okay, thank you.
Look at you, little brain buff Caitlin, coming out of the woodworks. I love it. Okay, so angle A is going to equal 58 degrees, and our reason is going to be tan chord theorem. Okay, so now tan chord theorem, I think I'm just going to highlight it on our picture because it might make it a little bit easier to see. Here's our tangent, all right? And here is our windsurf, the actual windsurfing situation, okay? And this is where our person is who's windsurfing. So they're holding on to the wind, and the angle that they're looking at is the one that's going to be the same. So this angle here is going to be 58 degrees. Caitlin, I see your hand. Is it a new hand or is it an old hand? No, it's old hand. Okay. Cool. So that's our tan chord theorem. Beautiful. All right, we've done A. Let's have a look at B. I don't want to have to help you too much here. I want you to try and think of your reasons. Who thinks that they can give me the answer for B? I don't mind if you're wrong. Give it your best go. Chuck those answers in the chat. Send them as direct messages if you're stressed. But I'm trying to figure out what B is equal to. So what this angle over here is equal to. I'm going to draw something for you. That might help. Yay! Look at these answers coming in. That's great. Yes. It is absolutely equal to 116. Yes, good. Okay, so B is equal to 116 degrees. Bonus points now. What is my reason? What is my reason? Yes, guys, nice. Angle at center equals 2 times angle at circumference. So all that's saying is that the angle at the center is equal to double the angle at my circumference. Beautiful. I love the answers coming in. That's great. Okay, so now we know. Let's pop that in over here. Oh, goodness. No, I'm writing. I'm not erasing. Okay, cool. So we know that that's, oh, no, we don't know that that's 2x. I'm being a little bit of a doofus right now. We know that that is 116 degrees. Cool. Okay. So we've done A, we've done B. Now let's have a look at C. So C is this dude in here. Don't overthink it. It's easier than it seems. That's my advice for C. There's something that's been given to you that's easily overlooked. Let me put it that way. Okay, I'm seeing some good answers coming in. Keep them coming. I can tell you it's not 32. So if you've said 32, then that's not what it's going to land at being. You got to work all the way back to grade 8 for this reason. Before circles became anything. Yeah, 58. There we go. Why is it 58? What is my reason? Why is it equal to 58 degrees? Yes, alternate angles, guys. Alternate angles are equal. Now, whenever we say alternate angles, we have to say which lines are parallel. So we're going to say BC is parallel to TN. Glorious. Nice job. Okay. Next one. Yeah, no, it's okay. You just had the wrong angle, but what you had written, no, don't apologize. What you'd written was good. Your reasons were good. So please don't panic. Just maybe double read the question twice, just so you don't do that in a test, because that would be very sad. Okay, so now we know that angle C is equal to 58 degrees because of our alternate angles, our little Z. Okay, now the last one we have to try and figure out is D. So that's in there. Now I would like to know, when you give me your answers here, because I know you're gonna be little brain buffs and you're gonna jump into your answers. I want the answer and I want the reason. So I want the answer and then I want the reason put in brackets. Oh, I think you're forgetting about another angle. I think you're forgetting about this angle in here when you're doing angles on a straight line. Yeah. Think about right in the beginning of this question when I said that if they tell us that we have a tangent, we want to look at two different things. We want to look to see if there's tan chord and we want to see if there's this dude here. So the answers that are coming in with 32 degrees, you are absolutely right. I want to see your reasons. I want to see a good, beautiful reason. And it's a nice, easy reason. It's like it's not a mission. It's a nice, quick one. Okay, so Brooklyn, technically, you could do that, but you would first have to work out this angle over here. Where I've drawn that little purple dot, you would have to work out that angle. Otherwise, we can't use angles on a straight line because we don't have all four of those angles. Tan chord theorem, it's not tan chord theorem because if you have a look at where D is, if you were imagining our little windsurfing situation, he's inside the windsurfer. Yes, there we go. Radii perpendicular to the tangent. Yes. We got there, we got there. Okay, so now we just have to be careful with how we write this out. Okay, we first have to say that we know that that's 90 degrees. So we actually first need to say that angle TAO is equal to 90 degrees. And our reason for that is nice and simple. All we have to say is tan perpendicular to rad. So all that that's saying is that our tangent is perpendicular to our radius. Okay, which is what we knew over here. So the tangent is perpendicular to the radius. Let me just write that in over here. So we knew and take a screenshot. It's there. Cool. So now we know that that's 90 degrees. That means we know that C plus D is equal to 90 degrees. We know already that C is 58 degrees. And so if we know what C is, working out D isn't so bad. So we're going to say D is equal to 90 minus 58, which means that D is equal to 32 degrees. Okay, we've got 3 minutes before I have to jump onto